You're driving down the highway and something so good is playing through the speakers that you've already missed your turn twice. Volume all the way up, windows rattling, bass thumping in your chest. And then you need to parallel park on some street you've never been to, in the dark, between two cars that were clearly parked by someone with their eyes closed. And without even thinking about it, you reach for the volume knob and crank it all the way down. The music goes silent, and suddenly the road ahead looks clearer, like somebody just wiped your windshield from the inside of your skull. Wait, what just happened? You killed the sound so your eyes would work better. Ears and eyes are two completely different organs with different nerves, different receptors. They're not even in the same part of your head. What do your speakers have to do with parallel parking? Turns out, everything. And to understand why, we need to talk about a gorilla that nobody noticed. A group of Israeli teenagers who nearly killed themselves to their favorite songs. And the reason airplane food tastes like cardboard. Because all of these are pieces of the same story. A story about a brain that works nothing like you think it does. In 1999, two psychologists from Harvard, Daniel Simons and Christopher Chabris, ran one of the most famous experiments in the history of cognitive science. They showed 192 volunteers a video of 6 people passing a basketball around and asked them to count the passes. Simple task, almost childish. But while people were counting the ball, a person in a full gorilla costume walked right into the middle of the frame, beat their chest, and walked off. 9 seconds on screen. And 42% of viewers didn't see them at all. Not in a they weren't paying attention kind of way. Their eyes were open. The gorilla was right there. But the brain decided the basketball passes were more important and just edited the gorilla out of the picture like it never existed. Scientists called this inattentional blindness. The idea is simple. Your brain has a hard cap on how much information it can process. When you load it up with one task, it physically cannot handle a second one. So it starts cutting, quietly and without asking your permission. But Simons and Chabris were only working with the eyes. What happens if you overload a different sense, like hearing? 12 years after the gorilla, cognitive psychologist Nili Levy at University College London asked exactly that question. She sat people in front of a screen with a visual task. They had to quickly judge which arm of a cross was longer. One version of the task was easy, the other was hard. And while people stared at the crosses, a clear, loud tone was played directly into their headphones. Not buried in noise, not hidden in other sounds, just a pure tone, right in their ear. In the easy version, almost everyone heard it. In the hard version, 79% didn't notice it at all. They were, in Levy's words, inattentionally deaf. Their eyes were working so hard that their ears basically shut down. And here's the key part. This works both ways. If the ears are busy, the eyes suffer. In 2007, a team of European neuroscientists led by Greg Hine put volunteers into a brain scanner and showed them an image at the same time as an audio signal. When the brain was busy processing the sound, activity in the visual cortex dropped. Sound was literally dimming their sight at the level of individual neurons. So when you twist the volume knob to 0 before parking, you're not performing some meaningless ritual. You're freeing up the only dispatcher in your head, the prefrontal cortex, so it can redirect resources from music to vision. And that dispatcher, by the way, has a very small office. In 1974, British psychologist Alan Baddeley described a model of working memory that's still the standard today. According to Baddeley, your brain has a phonological loop that processes sound, a visuospatial sketchpad that processes images and spatial information, and a central executive, the dispatcher, that coordinates all of it at once. The problem is that there's only one central executive, and there are a lot of tasks. When you're parking, the sketchpad is maxed out, calculating distances and angles. Meanwhile, the phonological loop is stuck on the chorus of whatever you were listening to 3 minutes ago. And the dispatcher does what any reasonable manager would do when the deadline is on fire. It kills the music. Or, if you didn't reach for the knob in time, it kills a chunk of your vision, and that's when you don't notice the curb. Okay, you might say, I get the theory. But does music really affect driving that much? Maybe this is all just lab stuff that falls apart in real life? In 2013, music psychologist Warren Brodsky from Ben Gurion University in Israel ran an experiment funded by Israel's National Road Safety Authority. Fun fact, Israel is still the only country on earth that has ever spent government money to study music behind the wheel. Which, if you think about it, is kind of weird. Brodsky took 85 young drivers, 17 and 18-year-olds, with about 7 months of driving experience on average, and sent each one on 6 40-minute drives on real roads. An instructor sat in the passenger seat. A data recorder was mounted in the car. 3 of the drives were with music the teenagers picked themselves. 3 were with no music or with a specially designed calm playlist. The results were brutal. When the teenagers drove to their own music, 98% of them made dangerous moves, speeding, tailgating, drifting out of their lane, driving with one hand. 1 in 3 needed a verbal warning from the instructor, and in 17 out of 85 drives, the instructor had to grab the wheel or hit the brakes to prevent a crash. 1 in 5 drives with their favorite songs nearly ended in an accident. Without music, things weren't perfect either. 92% still made mistakes because driving is just hard. But when Brodsky switched in a calm playlist he developed with Israeli composer Mika Kisner, errors dropped by another 20%. One more detail Brodsky recorded. The teenagers were listening to their music at roughly 120 to 130 decibels. For reference, a chainsaw puts out about 110. They were sitting inside a wall of sound louder than a power tool and trying to judge the distance to a bumper. And if you think your senses only fight each other behind the wheel, think back to the last time you ate on an airplane and tried to figure out why the chicken tasted like its own packaging. Usually, people blame the airline catering, and honestly, fair enough. But there's another reason you probably never thought about. In 2015, researchers at Cornell University found that at noise levels typical of an airplane cabin, 85 decibels and above, your perception of sweet and salty flavors gets suppressed. Noise literally drowns out your taste buds. But your sense of umami actually gets stronger. And that's exactly why Lufthansa sells almost as much tomato juice on board as it does beer. About 53,000 gallons of juice versus roughly 59,000 gallons of beer every year. In a country that considers itself a beer nation. Tomato juice is pure umami, and at cruising altitude, surrounded by engine roar, it hits the one flavor your brain can still pick up. The same cross-modal theft happens in restaurants. Oxford professor Charles Spence, one of the leading researchers in multisensory perception, points out that noise in busy restaurants often exceeds 90 to 100 decibels. At that level, dessert tastes less sweet, wine smells less rich, and you leave less satisfied with dinner. You thought the restaurant was bad. Turns out it was just too loud. And if you think only regular people fall into this trap, surgeons deal with the same thing. A survey of 171 operating room staff in Israel found that 63% of surgeons regularly listen to music during surgery. And when researchers from Imperial College London reviewed 35 hours of operating room footage, they found that when music was playing, surgeons and nurses had to repeat requests to each other 5 times more often. Music was drowning out communication in the exact same way it drowns out your vision in a parking lot. One last question. Why is the brain built this way in the first place? Why can't it just handle everything at once? The answer probably goes deeper than parking lots and playlists. When a deer spots a predator in the distance, it doesn't run right away. First, it freezes completely. Its heart rate drops. Neurobiologists call this fear bradycardia, muscles lock up. And most importantly, the deer stops making any sound. A frozen body doesn't snap twigs or rustle leaves. The silence sharpens the deer's own hearing and removes the acoustic signal a predator could lock onto. In 2019, researchers at the University of Padua showed that even baby chicks who have never seen a predator in their lives automatically slow down and freeze when a moving object approaches. The "shut up and look" response isn't learned. It's been hardwired into the vertebrate nervous system over 200 million years of evolution. And when you reach for the volume knob on a dark, unfamiliar street, your brain is, broadly speaking, doing the same thing. It creates silence to sharpen vision. It freezes to better assess the situation. 200 million years ago, this reflex saved your ancestors from wolves. Today, it saves you from curbs. So the next time your friend in the passenger seat laughs at you for killing the music before you park, you can explain, "You're not weird. You're a deer. A very civilized deer with great taste in music and an evolutionary reflex that's 200 million years old."